Today we are going to cover what is the loop in the networks, how to prevent these loops, and what is spanning tree protocol, what are the different terminologies used in this protocol like root bridge, designated ports, and how these elections work, and what is the different states of these ports, and how Portfast and BPDU Guard can help you prevent some of the security risks. Those who don't know me, my name is Vakas and I will be covering CCNA, NP and IE. Please like and subscribe the channel and hit the bell icon so you can be notified for the upcoming videos. Let's get started. Just a quick background of spanning tree protocol and rapid spanning tree protocol. This was standardized in 1990 under the standard IEEE 802.1d. And after that one, IEEE released Rapid Spanning Tree Protocol under 802.1w standard, which was finally added into the same standard 802.1d in 2004. Now they both are part of the same standard. What is the difference between both? That is what we will be trying to understand and why you need it. Let's first try to understand why you need a spanning tree protocol. What is the purpose of it? Let's assume that we have PC1 and PC2. And PC1 tries to ping PC2. Okay, what's going to happen? It's going to resolve the arc, and switch 1 will send out the frames from both of its interfaces since it does not know where that PC2 is. It will be received by Giga Ethernet 0/0 on switch 2, and since switch 2 also don't know it yet, it will be broadcasting from Giga Ethernet 0/1 to the PC2. What's going to happen? Now if you look into the diagram, switch 3 will receive that packet and it will forward it from the other interface as well. And this process can continue for indefinite time. The packet will keep looping and reaching to switch 1 from Giga Ethernet 0/1. If this thing continues, what will happen? Finally, this whole network is gonna choke. None of the pieces will be able to communicate with each other. There will be no communication. So that is where the spanning tree comes in. Once the spanning tree is enabled, what's going to happen is spanning tree will be electing who will be the root. It will be electing the root ports, designated ports, and finally it will block one of the ports. For example, it blocks this one. The communication starts from here. Okay, it's not gonna be accepted by switch 3 on this port. All the communication will be always be in unidirectional. So that's why you need a spanning tree protocol which will help you eliminate this kind of loops in the network, and it will be always selecting root ports, root bridges, and finally it will be blocking one of the ports on the network which will be preventing this kind of loop. This is not a permanent block. Anytime, let's say there is a topology change and it requires to be active again, it will be activated. There are a few important concepts in spanning tree, that what is root, what is designated ports, what is the root cost, and what is bridge ID. We will try to understand each and every concept, and we will even try to look into the examples as well. If you notice, I have written STP and RSTP together. I'm referring it as one term for now. We will try to look into the differences. What are the port states in spanning tree? It could be listening, learning, forwarding, blocking. And when it comes to rapid spanning tree protocol, it could be discarding as well. In that one, it's actually the alternative name of blocking. What happens? Which ports will be in forwarding? Which ports will be in blocking state? There are few rules for that one. For example, all the ports on the root will be always in the forwarding state. Now we will try to understand how the STP does this whole part, how it prevents the looping in the network. The moment it detects there is a switch connected, what it does, it runs that algorithms to select the root bridges. Okay, it will be selecting the root bridge in the network. So this will be becoming the superior switch in the network. Finally, the least switch in the network will have one port getting blocked or multiple ports getting blocked to prevent the loop. We can assume now that switch 1 has become the root bridge. On the switch 2, what's going to happen is it will be having its Giga Ethernet 0/0 as RP, which is called root ports. Root port, what it is, it provides the least cost to reach the switch 1. If you notice that it can directly reach the switch 1, so it will be definitely least cost. On the other port, it will become designated port. What designated port is, on each LAN segment, it will be selecting one designated port. And what will be the ports of the root bridge called? It will be all in the designated mode. Okay, both of them will be in designated port. The reason, because it needs to be in forwarding. Otherwise, how others are going to reach it? The switch 3, now let's assume that switch 3 has the bad bridge ID. We will look into what is bridge ID. The switch 3, what will happen is this port will become an RP, which is called root port. The other port, since we already have a designated port on this side, what's going to happen? It's going to get blocked. Why this port will get blocked? That is what we will try to understand, which ports will be getting blocked in the network. Just a quick note, there are few important concepts you should try to understand. Pause my video, look into the concept again, and let me know if you have any question. The concepts you need to understand is like, what is root, what is bridge ID, what is system ID, how these election works, what is designated port, what is root ports, and what is root cost. The first concept we need to understand in detail is what is bridge ID, because all these elections are going to happen based on this one. The bridge ID is made up of 8 bytes. 2 of bytes are assigned for priority. Or by default, all the systems have the priority 32768. The other 6 bytes are assigned for system ID. The system ID basically is a unique MAC address. We also call it sometimes burned MAC address. The burned MAC address, when you ship a switch, it will be always having one unique MAC address which is going to identify that switch. And if you notice in the screenshot, it is having one root ID and one is bridge ID. So what it is mentioning, who is the root in the network? These IDs belongs to that switch. For now, this switch itself is a root. You will see the matching information. What will be my bridge ID will be, it will be the priority and my burned MAC address. Make sense? The other concept here is sender bridge ID. What is sender bridge ID is who is forwarding that packet. Okay, for example, I am speaking to switch 2. What will be my sender ID? That will be my bridge ID. What is the sender root cost? That cost means what is the link cost to reach the root switch. Each link could have a cost depending on the speed. Now we will try to understand how this selection process works and what are the steps to eliminate the loop. The first thing in the network it needs to do is to select the root. Each switch will become root. It will be based on its bridge ID. The lowest bridge ID in the network will become the root switch for that whole segment. All right. The second thing it needs to do is what will be the root ports? Which one have the least cost to reach the root bridge? That will become root port. Then it will be creating an election for each LAN segment to select the designated ports. These designated ports will offer the least cost to reach the root bridge. Let's look into more details of the selection. For example, on the screen, if you notice, we have switch 1 and 2 and 3. By default, the moment these switches comes up and the interfaces are up, what's going to happen? Everyone will try to broadcast to other switches, mentioning they are the superior switches. By default, all the root cost is 0 on the root bridge. Everyone will send a packet saying, I am the superior. And it says my BID. BID is a bridge ID. What is my bridge ID? The bridge ID is made up of priority 32769 and its burned MAC address. The next one, root bridge ID. It will be assuming itself to be a root. every switch will be doing the same. It will be continuously keep sending to the other switches. For example, switch 1 sends to the switch 2, I am the root. Switch 2 will be mentioning, no, I am the root. And switch 1 will be also communicating with switch 3 that I want to be root, and switch 3 will be also be part of the same election. What's going to happen, because if you notice that on switch 1 the bridge ID is lower than the switch 2, switch 1 will be elected as root. Switch 2 will step down, and now it will send another BPDU, bridge protocol data unit, to, so it will send a BPDU mentioning that my bridge ID is this one, but I have a root bridge ID after the election. I selected someone, and it will be sent to switch 3. And switch 3, since it also received it from switch 1, will be forwarding, yes, I also have the same. By default, on this link also there will be election that they will be also mentioning my root cost is 0, my bridge ID is this, and root ID is this. So they will be also doing the same. But just to understand this part, finally switch 3 will be sending to switch 4 that I found a root on lower priority, and the other one also found this same information from switch 1. In this whole design, we found out the root is going to be switch 1. There are two reasons: because of their priority and because of their lowest MAC address. Now, if you remember that, what was the second step? It's gonna select which ports are going to be root ports in the network. In step 1, they selected that switch 1 is going to be root in our design. What will be the root ports in this whole network? That election is going to be based on port cost. All right. Every port has different cost. I will put the link where you can see different cost for each link. But by default, let's assume for our scenario it is 4 on all the links. Okay. Which one is going to be providing the least cost to reach the root? From switch 2, if you notice, my cost is going to be 4. All right. And from switch 3, on this interface, my root cost is going to be 4 as well. But from here, if I try to understand from switch 3 side, it will be requiring this connection to be established. Let's say 4 plus 4. So my cost is going to be 8 on this link. From switch 2, Gig Ethernet 0/0 provides the least cost. This becomes the RP. And from switch 3, Gig Ethernet 0/0 provides the cost 4. So this one becomes RP. But these two, if you notice, the cost from here to reach the switch 1, it's gonna be 8. And if switch 2 tries to reach the root bridge from Gig Ethernet 0/1, it's also gonna be 8. Now we have selected which links are providing me the least cost. I will be selecting it as a root ports. Now it's time to understand how the designated ports get selected. In the earlier step 1 and step 2, we have already selected which one will be the root switch and which one will be the root ports. Let's select the designated ports on the root switch. The root switch will be having the least cost to reach itself. So all the ports of root switch will become designated ports. All right, both of them will be designated ports. The problem comes in between switch 2 and switch 3. If switch 3 tries to use this interface or switch 2 tries to use this interface, the cost on this link is going to be 8 to reach the bridge. The reason, this one is 4 and this one is 4, so total 8. Once the cost is equal, how this tie is going to be? Which one will be designated port? What is going to happen is, if everything is default, either we change the cost on the interface to give more priority, okay, or we can leave everything by default and spanning tree will automatically take care of it. Spanning tree will be selecting the designated port based on the least bridge ID. In this one, if you notice that the bridge ID for Switch 2 is this one, and switch 3 is 333. Okay, the least one is switch 2. So this port will be selected as designated port. And now we have selected which one will be our root bridge, which one will be designated ports, which one will be root ports. Now it's time to look into the remaining ports. Finally, the port which have no status technically, all right, is gonna get blocked. In this diagram, if you notice that we have all the ports assigned with their status, so this port is finally going to get blocked. The status of this port will be either blocked if it is running STP. If it's running RSTP, it could be in the discarding stage. The other status is disabled. Let's say if you have another switch connected here and you have administratively shut it down, what's going to happen? This will be as a disabled stage. That's how the election works. That's how we select all the ports and everything. Now we can quickly look into the STP timers. And if you notice in the screenshot, we have by default timers for STP. There is a difference between STP timer and RSTP timers. STP timers, the hello is 2 seconds and max age is going to be 10 times the hello. So for example, hello is 2 is going to be 20. If it is 3, it's going to be 30. The forward delay is going to be 15 seconds. Let's try to understand what these timers does. Assume that switch 3, this port is blocked and this interface also have an issue. Now what's going to happen? Both of the interfaces are down for now, right? What's going to happen is it will be waiting for its max age before trying to change the topology in the network. For example, the default one was hello time was 2 and max age was 10 times the hello, it's 20 seconds. After 20 seconds, it will try to change the stage. Blocking, it's not basically processing any BPDU on this one, or no frames are processed here. Okay, on the block stage it will be converting it to listening after 15 seconds, which is basically the forward delay. After 15 seconds in listening, what happens, I started listening to the frames coming in, but I'm not processing it still. Why I'm not processing it? It could be a temporary issue in the network or temporary loop in the network which could be preventing that communication. So I'm just waiting before I could completely change the network. The next mode is learning. In learning mode, what's going to happen is I will be flushing out my MAC address table entries which are aging. I will be removing all those entries, and now I will start changing the mode from learning to forwarding. In this stage, what's going to happen? I will be actively processing the frames, max, and so this port will become the forwarding stage and the cross will be removed basically. The whole transition period could take around 50 seconds, starting from blocking to listening, learning, and forwarding before the port becomes active. In RSTP, that time is reduced. We will see into that as well. Now let's compare STP and Rapid Spanning Tree Protocol, that what is the differences are. So what kind of modification IEEE did in Rapid Spanning Tree Protocol is they introduced the mechanisms to immediately replace the root ports in case of failure, place the designated ports, and even they reduce the timers in this one. Rapid Spanning Tree Protocol introduced 2 seconds on hello and 3 times max age. In STP, if you remember, it was 10 times, it was 20 seconds. These are the major differences in RSTP, and even the stages are different in this one, like they name the ports differently. We will look into the next slide. The other difference is it can even inquire from their neighbors that if there is any topology change, rather than assuming itself that there is a change. What is the difference between RSTP Interface States? If you remember, in STP we was having root ports, designated ports, root bridges. That concept is still valid. There is no issues. In Rapid Spanning Tree Protocol, what they did, since the mechanisms are modified, it's little advanced than STP. They introduce the alternative port. This alternative port will be acting as root port in case the earlier root port is failed. And they introduce the concept of backup ports as well, which will be acting as standby for designated ports. Look into the diagram. For example, you have a designated port, you have root ports. On the root port, they introduce the concept of alternative. For example, if this goes down, it will switch. It will automatically activate this one immediately without any delays. And in STP, it was 50 seconds. If it is designated port, they introduced backup ports. In case this one goes down, automatically activate the designated port from the other side. The blocking stage, if you remember, now it is called discarding stage, which is acting as same. And the last one, disabled port, that concept is same as STP. If you put into the shutdown mode, it will be status as disabled port. That's the major difference. Now it's time to understand what are the different modes for RSTP interfaces. For example, there could be point-to-point, point-to-point, edge, or shared ports. The difference is very simple. If it is connected to a single host, which is basically, if it is a switch, then it will be called P2P, also called point-to-point. If it is an access port and there is a device like computer or printer or IP phone, then it will be point-to-point edge. And if it is a hub or any network which have the shared computers on the other side, that's mean it's gonna be named as shared port. Hope you got the idea how STP works, RSTP works, and what are the different modes of it, and what is root bridge, root ports, designated ports. Now it's time to understand what is Portfast. If you remember the STP takes around 50 seconds for the transition from blocking to forwarding mode. In some cases, that delay is too much. Why the access port has to wait to come from listening, learning, forwarding stage. This thing we can avoid by using the Portfast. If you enable a Portfast on that interface, what's going to happen is it will be immediately going from disabled or blocking stage directly to forwarding stage. This delay will be very minimal. It is always recommended to enable it only on the ports where access devices are connected, not on the trunks. Even if sometimes some switches have the warning as well that you cannot enable it on the trunk interfaces, but if some switches does not have it and you enable it, what's going to happen? You could introduce a loop, or you can introduce a temporary loop in the network. For example, the change was temporary and the interface from blocking to forwarding immediately came up. So what's going to happen? The whole topology has to reconverge to make that whole communication up. So what happens in BPDU Guard is when the topology is coming up, let's say switch 2 has sent a BPDU message to switch 1 with this bridge ID, and it sent that what is the root bridge ID, and the election happened on this interface. Suddenly someone comes from nowhere, an attacker comes up and he connects a rogue switch in that and provides the least bridge ID and introduce into the network. What's going to happen? This whole spanning tree topology will be reconverged. The election will be starting. Since there is a network change here, what's going to happen? It will send its lowest bridge ID to the switch 1 and the convergence will happen, and this switch will become root in that case. Now the attacker can use this advantage to become a root to its favor. For example, it can reroute the whole traffic to himself and launch a man in the middle attack. We will see in one of the lectures that what are these attacks are. Or it can completely discard those traffic which are coming to that switch. Or it can initiate a packet capture. That's the reason that we use BPDU Guard. If you enable a BPDU Guard on this interface, The moment this interface receives the BPDU packet, it's gonna put interface into disable mode, and we call it error disable mode as well, which will be requiring someone to recover that interface, or there could be a timer to recover that automatically. That's how the BPDU Guard works. That's it for spanning tree and rapid spanning tree. In the next lecture, we will try to understand how the per VLAN spanning tree works, and how MSTP works, and rapid PVST works, and what is the difference between all these protocols, which one is running by default. If I have increased your knowledge in any ways, please hit like and subscribe. I will be covering CCNA, NP, and IE. I want you to be expert of networking. Take care.